Welcome back, everybody. It is day 5. We have 8 stars, and we're about to get 2 more. It's Advent of Code. We do this every day for like, I don't know, 7 days, and then I give up. We'll see how far I get. But hopefully day 5 is nice and easy. Let's dive right into the problem. As always, we're going to be doing it here in Elm. Hello. We're going to write code on the left. We're going to see the output on the right, and step by step, we're going to work through the problem. So let's figure out what today's coding challenge is. Day 5 prep queue. Satisfied with their search on series, the squadron of scholars suggests subsequently scanning the stationary stacks of Subbasement 17. I think they're trying to trip me up with the S's. I didn't miss a beat. The North Pole printing department is busier than ever this close to Christmas, and while the historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons you over. The elf must recognize you because they waste no time explaining that the new Sleigh Launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed, so you offer your services. Safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation X pipe Y means that if both page number X and page number Y are to be produced as a part of an update, page number X must be printed at some point before page number Y. The elf has for you both the page ordering rules and the pages to produce in each update, which is our puzzle input, but can't figure out whether each update has the pages in the right order. So this is a lot of numbers. All right, so we got all these numbers here. The first section specifies the page ordering rules, 1 per line. The first rule, 4753, means that if an update includes both page number 47 and page number 53, then page number 47 must be printed at some point before page number 53. 47 doesn't necessarily need to be immediately before 53. Other pages are allowed to be in between. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in the updates are different too. The first update, 7547, all this stuff, means that the update consists of page numbers 7547, all that stuff. To get the printers going as soon as possible, start by identifying which updates are already in the right order. In the above example, the first update is in the right order. 75 is correctly first because there are rules that put each other page after it. 7547, 7561, 7553, 7529. So it looks like this has 75 in all these spots. So that seems to work. 47 is correctly second because 75 must be before it. And every other page, there's a 47 pipe 61. Oh, so these are kind of like directional like lookups. So like 47 can point to 53, that kind of thing. 61 is correctly in the middle because 75 is before it. Okay, so all these things are true. 29 is the only page left, so it is allowed to be. Because the first update does not include some page numbers, the ordering rules involving those missing page numbers are ignored. The second and third updates are also in the correct order according to the rules. So let me see if I can figure that out. So 97, this is saying that 97 should have 61, 53, 29, and 13 after it. So if I look for 97, I should find 61, 53, 29, and 13. 61, 53, 29, and 13. Okay. And then this one is saying 53, 29, and 13. 53, 29, 13. Great. This one is saying 53 has a 29 and a 13. Yep. And then 29 should have a 13. It does. Okay. Cool. So that makes sense. The fourth update is not in the correct order because there's no 97. Fourth update is not in the correct order. It would print 75 before 97, which violates a rule. 97 always comes before 75. So it's saying always comes before. So it's not enough to not find it. You also have to... That's weird. So 75, it doesn't have a 97, which is reason enough, but do I also need to check if 97 has a 75? Like, that's weird. I'll have to keep that in mind as we're solving the problem. So it's saying X always comes before Y. X must be printed at some point before Y. Okay, so it's a rule. So they both seem to matter. So I'm gonna have to look for like each number. If I take like 75, I have to make sure there's no 47 that says 47 must come before 75. Interesting. Okay, I don't think this is too bad. Okay, so they need to know the middle page number for each update being printed. So if I get this, I need to get 61, 53, and 29. Adding these page numbers together gives you 143. The actual list of page ordering rules is bigger and more complicated, so let me just see what that looks like. Okay, we got more rules, and we got larger data sets. Okay, I think we can do this. I think this will be okay. So what do you get if you add up all the middle page numbers? So 143 is the answer that we want if we plug in this input. So let's try it out. Let's hop over here. Let's put in our puzzle input. We're calling string.trim. And so this is going to give us basically new lines separated everything. So what I want to do is I want to make a toPuzzle input function real quick. And what this is going to do is this is going to take in our string and it's going to give us back our codes, which is just going to be a list of strings separated, on each line. And then we're going to get our, what do they call it in the puzzle? I'm going to use the same. So it's rules, and then it's updates. So let's call it that, rules and updates. So my goal here is to take in that input string. We're going to say string.split. We're going to split on these double new lines. And if we get the rules, we get the updates, these will both be strings. Because we just split a string, we'll get two strings. We don't expect to find more than one new line. But basically, if we split this, we should be able to then call string lines on each. So rules is going to be string.lines on the rules string. And then updates should be string.lines on the updates string. And that'll be just that. You know what? I'm just going to put in dummy values if we don't parse it. Because I don't want to deal with all the maybes. At some point, I'm probably going to need to do that anyway. So let's see what happens. Cool. So what we just did with that code, let me format this and put on a new line, is we took this string and we kind of created this like puzzle input data structure. So I'm going to call this a puzzle input. And it's basically, we're just going to make a little nickname here. Puzzle input is going to equal this. And that's going to allow me to keep this all in one line. And when I snap everything into place, what we did is we took this crazy string and we broke it apart into these rules and these updates. So I think we can take it one step further and we can even say, let's turn this into rules and updates. So what I want to do, I think, is loop through all of these. Let's keep it as strings for now. What I want to do is I want to make it so that if you give me 47, I should be able to tell you like 53 comes after it. So I think what I want to do is kind of have like a lookup structure. Each time I find one of these pairs, I want to kind of index on like 47 and index on 53. So you can say like, hey, I have 47. Like what are all the numbers that can't come after it? And what are all the numbers that can? That sort of thing. So I'm going to make a similar thing here. I'm going to call this rule lookups allowed. So if I give you a certain like thing like 47, you have to give me, I guess these will be integers. And then this is going to be like disallowed. So a dictionary is going to allow me to kind of like look up both ways. So what I want to do is I want to say, let's take our puzzle input. I'm just going to grab the rules thing for now. So let's just kind of focus on the rules. Let me import dictionary. Expoisoing. Oh, I don't have the oi. Oh, what the heck? What did my mouth just do? So what I did with this dot rules is I said, let's just only grab the rules field for now so we can kind of look at that. And I'm going to say this two rules lookup. And so two rule lookups. This is going to take in that list of strings that we had, and it's going to basically build up. It's going to build up our rule lookups. So I think what I want is something closer to this. So what I'm going to do is I'm going to do a list.fold L, where it's going to take each string one at a time, and starting with basically empty dictionaries for allowed. And empty dictionaries for disallowed. There's a shortcut to do this in Elm where we kind of use rule lookups as its own constructor. So I'm going to do that just so we don't have to duplicate the field names. Although generally I prefer using the record names. I think it's a little easier to understand for beginners. Okay, so I'm going to do that, and then what we need to do is we need to take in like one of these strings, and the goal is when we get one of these strings, we need to update our lookups. So this is going to be like our string here. We're going to have our lookups, and we need to return like the new one. What's the new updated lookups? So the way I'm thinking about going about this is like we're going to take the lookups and we're going to insert like 47. We're going to say allowed is insert 47, put in 53 for the existing allowed. And then we're going to kind of like do the same with disallowed. So this is actually really close to what the branch is going to be, but just specific to these numbers. But the idea is with disallowed is I'm going to make it really easy for us to look up like, hey, is it not okay? Like if I have a 53, are there any numbers that shouldn't show up after? But this might be premature optimization here. I don't know if we're going to need this or not. So I'm just going to leave this as is. But that's the idea. We're going to basically update our dictionaries and insert these numbers. So I'm going to start by saying split this string on pipe. And then we should get two numbers. We should get our kind of first number and our second number. And then we shouldn't get anything else. So what we want to do there is we want to say, once we split the strings, I'm going to do a little bit more processing here. I'm going to say we're going to split the string with the pipe. And then we are also going to run list.filterMap to turn them into numbers. So string.toInt. We're going to kind of do this all here. And then the goal is we are going to say if we successfully got two numbers back, it means it's valid input. we're gonna do what I typed here. But the idea is we're gonna say it's okay for the first to find the second, but it is not okay for the second to come before the first. And I gotta make sure to say lookups dot disallowed and lookups dot allowed, and that is going to kind of use the existing thing. So that's the new value that we'll return. And then for everything else, we're just going to leave the lookups alone. If we have an invalid string, that's totally fine. We're just going to ignore it. Two rules lookup. Yeah, I'm going to call it that. I don't really care. This is a silly name. Oh, almost there. Okay. So what this is saying is that it is allowed to go from 29 to 13. So we see that here. It is allowed to go from 47 to 29. All these are in the allowed list. But what you're not allowed to do is kind of go backwards here. So I think, is that enough rules? 1, 2, 3, 4. Are there duplicates? Like I'm trying to figure out. Oh my goodness, I'm inserting, I'm not like adding multiple. That's a problem. 47 is gonna have multiple entries, not just one entry. So every time I insert this, I'm like totally destroying the old key. So what we want to do is we want to call an update. And so what update's gonna do is rather than, let me kind of get this code over here. Let's kind of do this in a pipeline style. Update is going to take in a key and it's going to have like an updater here. So we're going to say add first and second. What add's going to do is it's going to take in a number. It's going to take in, maybe a list of numbers, and it's going to return a maybe list of numbers. So we want to use dict update, and we want our rules lookups not to point to a single thing, but actually probably a set, because sets are easier to say. What's allowed? Allowed 47. I'm trying to think this through. 47 set. Yeah, this is good. All right, we're gonna use a set. A set allows us to eliminate duplicates and quickly check the values there. So instead of a list, I want to use a set. So what we're gonna do is we're gonna say there's some value that we want to add to our set. Maybe we have a set, maybe we don't. This could be the first time we've hit 29 in the loop, for example. So what we're gonna do is we're gonna say in the case where this is nothing, that's all right. We're going to return set.singleton with that value. And in the case that we have a set, like some existing set, like we've previously inserted at 47, we're still going to return a set, but we're going to do set.insert that value, the existing set. So now we have a lot more entries, which is great. So what we should see is for the number 47, see how 47 shows up 1, 2, 3, 4 times on the left? We should see 1, 2, 3, 4 entries in our allowed list. And when we look up 47 in the disallow list, we should see 2 entries because we see it show up twice on the right. So if I said what are the disallowed numbers for 47, what can't come after it, it's going to give me 97 and 75. And sure enough, that's what it does. So we've kind of taken this crazy string and we've made it so we can easily say dict.get, and that'll give us a set where we can say set.member, and we'll be able to loop through this list left to right and say hey, make sure that none of these show up in the disallowed, and all of them show up in the allowed. And I think that's the algorithm that we have to write. So that's the rules. So I'm gonna say to data structure. I'm just gonna call this like a model, to model. And so our model is gonna kind of have everything we really want here. So if I do puzzle input.rules, this is going to be like one more level above, just like the raw strings we were working with. I'll say to valid updates. I'll call this lookup. And we are just going to return, I'll get to valid updates. I changed my name on the, changed my mind on the intermediate like data structure. I don't think it's really necessary. All right, so we've got puzzle input.updates. That should be a list of strings. Let me run this. Okay, so we get our list of strings. What I want to do is say for each of these, let's loop through it, and let's do a filter map on string.split. So we're going to take the string, we're going to split it on commas, and then we are going to, should I use the fancy operator? This allows me to kind of chain functions together. I'm going to use it. List.filter map string.toInt. Hopefully this gives me a list of ints. So see how these are actual like numbers now? Now that I have a list of ints, I'm going to be able to loop through them and determine if something's valid or not. So I'm going to say list.filter is valid update. And so is valid update is going to take in a single list of integers. So it's going to take in a list of integers, and it's going to return a Boolean, true or false. Should we keep it? Should we not keep it? So an update is valid if you look at the numbers and there's nothing left. That's one way that we can say like, yeah, that's a valid update. That's like kind of our base case. The other way you can do it is if there's one number with nothing behind it, that's valid. So if you get to the end, 29 is valid because there's no trailing numbers. But if you have first thing and then you've got like the rest of the numbers, this is when we're going to want to use our lookup to determine like, hey, are there any items in the list that are members of disallowed? Are there are all the members of the list in the allowed? So we can say list.all is in allowed and pass in the first number for rest. So every single one of these numbers should show up, and list.any is in disallowed. We want to make sure that none of them are in the disallowed. So we're going to say first for the rest of the numbers. So I think this is right. So we could say not list any, or we could say list.all not. I think this is a little bit easier for us. So is in allowed takes in a number, and it takes in one at a time. It'll take in kind of like the value that we're looking for, and return a Boolean, true or false. So this is the first number, and this is the next number. So if we're looking at the first number, 75, and we're comparing that to the next number, it's in the allowed list if dict.get first lookup.allowed. So that'll give us the set, maybe .map set.member next. And then basically if we can't find, so if we look up 75 and we get a set back, we're going to say is next a member of that set. So does 47 show up in that set? And if we don't get a set back, that means 75 never showed up. So we always want to return false. So this is the same as saying in the case where we get a set back, let me know if it shows up in the set. This is how I would write it if I was writing it at work. Because I generally avoid using these maybe.maps and the maybe like with defaults, because I think this is easier for folks to read, easier for people maybe not familiar with Elm to hop in and know what the code's doing. So this is similar, but it's going to be different. What we're going to say is, does it show up on the side? So is it in disallowed? Well, if I look at what is not allowed and I find this next number, it is. Otherwise, it's not. So these functions are really similar. It's just using allowed instead of disallowed. So if we wanted to be really clever, we could say is in, and then we would provide the dictionary with the first and the next. And so this one would be the same as saying, instead of saying is in disallowed, we could say is in lookup dot disallowed. That's like the clever way of doing it. I'm going to leave it like this for now just to see if this logic is right, see if they're actually the same, because we might find out that this needs to be true. But I don't think it does, because this should always return false if there's no set. So let me hit compile. And what we get back is not all the lists, right? We got back this one, and this one. And it looks like we didn't get this, but 5 and 6 are coming back, which I don't think are supposed to, right? Not in the correct order because it breaks the rule 29 to 13. So let's take a closer look at what we're getting for this. 61, I'm going to take a look at the rules themselves. And the way I'm going to do that is I'm going to use a debug log here. Debug.log lookup. And so by doing this, we can look in the logs and see what the rules are that we get when we run this program. So 6113, 61. So when I look up 61, I get 13, 29, 53. 13 and 29 seem to be happy. Oh, I'm looking up my disallowed backwards. I think what I want to be doing is I want to be saying is 61 and 13's disallowed, because wait a minute. Disallowed. What is disallowed for 61? If a 13 shows up, it must be before. Oh, this is upset because 13 isn't before 29. Is that the issue? $29 comes before 13 is the issue. Oops. So let's see. 29 comes before 13. So I want to see where the 29s are. 29 always comes before 13. So this disallowed, I think, is backwards. Did I copy paste and put first and next in the wrong order? This is allowed. Second is disallowed. Disallowed 13. I think I need to look it up backwards. I think what I want to do is I want to put first here. I'm so glad we didn't reuse the code. Because now, oops. Oh, no, none of them are right. Let me think about this a little bit more. Let me see what we're doing. 16, 13, 29. All right, let's go through it like our program is. So I get to 61. And what I'm doing here, I've got the data over here. I'm saying it's a valid update if, given the list, we're at 61, 13, 29. So we come through the list the first time and we say, is this empty? It's not. Is it alone? It's not. Here this is 61 and rest is 13 and 29. So what we're saying is in allowed, we're going to pass in 61 and we're going to call it on 13 and 29 and we'll return true if when we look up 61, so if we hit the allowed list, we give it 61, do we find 13? We do. We say, is 29 a member of that set? It is, so we return true. And 29 comes back, which is good. The problem is we're not filtering enough, so this isn't the issue. But the next time we come in the list, it's valid update. Oh, we're not recursing at all. Oh my goodness. We're only checking the first thing. I forgot to do the final part, which is valid update the rest of the numbers. I forgot to keep going. This is the part of the recursion where it like recurses. My bad. And to make it so that it yeah, so I'm gonna say if I just want to make sure that this is stack safe. So if this is true, we will do the rest. Otherwise, this is false. I don't want to get infinite stack, but I forgot to do this part. We need to isValidate update on the rest. So I never got to the part where we were checking 13. So this might make it a little bit easier to get the problem right. So it looks like we've got this one's correct, this one's correct, this one's correct, but 4, 5, and 6 are wrong. So let's take a look. And I think that's what it was, right? It was saying first update, oops. First update is in the right order. Second and third update are in the right order. So this was the output that we just got. So it looks like we have the right output. Now we just need to make a function that takes a list and grabs the middle update because we need to add something. So we've filtered to the valid updates. Now we need to say filter map to middle number. This part's easy. It should be easy, we'll see. But what we're gonna do is you're gonna say, give me that list. And we're gonna say if list.length. I guess we'll just say list.drop. We'll take the list. We will drop half of the length of the list divided by 2. So if we have a 5, that's going to drop 2, and then we're going to grab the head, list.head, and this should give us a maybe int because we might have an empty list. So we're going to use filter map with a maybe, and that gives us 61, 53, and 29. Did I do that wrong? 3 divided by 2. Oh, sorry, we want to drop. Yeah, we want to round down. Did I do this wrong? Oh no, sorry, this is the one. Right. Yeah, 29, 61. Okay, 61, 53, 29. I think that's it. And then we're just gonna, it's my favorite part. It's a favorite part of admin code because I get to use list.sum. Boom, 143, 143. So I am going to go here. I'm gonna say day 5, part 1. I think it's day 5. I'm gonna hit the save button. This will be in the video description. So if you want to see the solution, if you want to run it for yourself, there it is. What I'm going to do now that I have it saved is I'm going to take my puzzle input and see if our program is efficient enough to run on this huge data set. Let's find out. 4814. And we got a gold star, so that's good. So part 2, they're gonna put a twist on it. Let's see if it's harder. Hopefully it's easier, and we get off pretty lucky. Okie dokie. While the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to put the page numbers in the right order. For the example above, here are the 3 incorrectly ordered updates and their correct orderings. So what we want to do is we want to shuffle these around. After taking only the incorrectly ordered updates and ordering them correctly, the middle page numbers are 47, 29, 47. Adding these together makes 1, 2, 3. So find the updates that are not in the correct order, and what do we get if we add up those middle numbers? Okay, so that's a little weird, but I think we can handle it. I'm gonna save this. Oops, I'm gonna undo, save this. 143, so we're where we left off. What we were doing before is we were going 2 valid updates. And 2 valid updates took in a puzzle input, and it returned us a list of lists of numbers, I think. So that's what these things are. These are updates. Let's make an alias for it here. So this is what our code was doing before, and that was working. That was giving us the 143. So if we kind of take a step back, this was us getting the middle numbers. Take another step back. This was us getting the correct items. So what we want to do instead of doing filter is we want to say, give me the ones that are not a valid update. And so I'm using these fancy pipes. This is basically saying take the item, run it through this, and then run it through the not function. So what we end up with here is all the invalid ones. So we need to use the rules to work our way left to right. So that's kind of crazy, right? So I think we're going to have to use our lookup in a creative way to figure out like what is a valid order, because I don't think shuffling brute force is going to work out too well. So what I want to do is, maybe shuffling works fine. What we need to do with these is we need to say, this is 2 invalid updates. And we're going to say for each one of these, we are going to, I guess we're going to have to pass the lookup through. So I'm going to do this here, 2 reordered. Invalid updates. I guess you could call those valid updates. Let's just leave the name as it was. But what I want to do here is say that these are the initial invalid updates. Great. And these are just a list of updates. But rather than returning these, what we're going to do is we're going to say list.map validate updates. And this might be a filter map when we get to it. We're just going to take these and we're going to try to shuffle them around. So what we need to do is we need to make a function that takes in an update and shuffles it around so that it's valid. So how are we going to do that? This is the question mark, right? So this is the new part of the code. I'm going to move it up towards the lookups. We can stop logging these for now. I'm going to comment this out. But I just want to... I'm going to say 2 valid update. Yeah, 2 valid update. And I'm going to pass in the lookup, because we're going to need that as context to be able to make these decisions. So this is the rules. Lookup, and then each of these is going to take in an update and return a valid update if it can. Lookup update equals update. So if I hit compile, nothing should change because we're not actually shuffling them around in any way. So what we need to do is we need to somehow use, I'm going to immediately put the debug log back in because I want to look at this and think about how we might do that. So what is a valid update or an invalid update? Maybe it's, let's start with a short one because that's probably the easiest one to think about. So if we had 16, 13, 29, we need to look at the what's allowed and kind of reorder them. Whew. I wonder if there's a smart way to do this. Look at the update. It's like almost a sort function that we need to write, because an update is a list of integers. I wonder if we can make a sort function that sorts this. So I'm gonna let's talk about 13, right? Oops. 13. I'm gonna move this back in just because I think I'm gonna want to reuse my is valid, is invalid functions. In which case I don't need to pass this. Oops. Sorry about that. In which case I don't need to pass the lookup in because it's already in scope, because it's right here. Let me just get this working. Formatted. Okay, great. Okay, that's our lookup. I'm just gonna add an annotation real quick. To that. Okay, and this doesn't take the lookup anymore. Okay, back to normal. So what I want to do is I want to shuffle these around based on the allowed. So if I look for 13, 13 says that 29 and 61 are allowed after. 29 says sorry, this is saying what isn't allowed. I'm going to try to sort these. I don't know if this is going to work. I'm going to try to sort these. I think this could do it, but I don't think I know what I'm talking about. Sort with. So Elm has a sort with function. And so you can basically make a function that given like a list of numbers, takes like one number and another number and returns an order. So we can say like less than, greater than, equal to. I want to see if this does it. So we're going to make our little sorter here. So sorter is going to take in one number, take in another number, and return an order. I'm going to prefix it with basics so you know where it's coming from, but really everything comes from basics. I usually do this. I'll leave it off. But I usually do it because I get type head when I'm dealing with the less than, greater than. So what I think we want is on the left, we want the things where the right is allowed. So if I can say if is in allowed A, B, if is in allowed and is in is not disallowed B. If it's allowed, if A is allowed in B to go before B, and it's not disallowed, I'm going to say it should go to the left of the list. I don't know if this is going to work, but it'd be cool if it did. Similarly, greater than. Else, I don't know. I just wonder what happens if I do this. Okay, let's see if that was right. 97, 75, 47, 61, 53. That was right. 61, 29, 13. That was right. 97, 75, 47, 29, 13. That worked. Is there a deeper mathematical truth here, or is this just incredibly lucky? I think the data set might be lucky, or I just like stumbled upon something amazing. Let's keep getting those middle numbers. Let's keep summing. 123 was the answer, right? I mean, that was the answer, dude. That's pretty sick. Let's see. Let's see if this worked. I'm gonna leave that because if I get rid of it. All right, let's save that. Copy. We're gonna put it here, and what if it works? What if it works? Oh, it could be free. 5448. That's a gold star. That I lucked out. I feel like I don't know what the equivalent is. It's just stumbling into something. I feel like it was a good spawn point, you know. It's just like I totally lucked out. That's day 5. We did it. I used a sort function. I kind of half used my intuition. You know, for some reason that was genius, and I'm a genius, and you saw it here, folks. Thank you for watching. I'll see you on day 6. We'll see if I pull that off again. Goodbye.